Let us now learn about the fructans. Fructan is a general term for any carbohydrate in which one more fructose unit is linked, constitute a majority of glycosidic bonds. They are linear or branch fructose oligopolymers. Fructosyl fructose linked inulins 2,6-levans. Inulins are mainly of plant origin containing 2 to 70 units, whereas levan are mostly produced by some fungi and many bacteria. Fungi, bacteria, inulin have much high degree of polymerization. Oligofructo, it's produced by enzymatic hydrolysis of inulin. Thus, as a food ingredient, they are available either as a native inulin or high molecular weight inulin, or enzymatically produce hydrolysate oligofructo. Synthetic fructans are mainly P-2.21 linked fructose with degree of polymerization of 2 to 4, industrially obtained by enzymatic synthesis from sucrose. Inulin type fructans are present in significant amount in various edible fruits and vegetable. The plant families such as Liliaceae, example asparagus, artichoke, garlic, leek, onion, banana and chicory roots. Fructans can ingested by consuming this food. In cereal parts of granine, particularly young seedling containing about 70% of their dry weight. The estimated daily intake in the Western countries is approximately 7 to 11 grams per day, depending on the type of food consumed. Because of their configuration, inulin type fructan are resistant to human digestive enzyme and in illinium due to microbial activity or enzymatic hydrolysis, with the remaining 86 to 88% of ingested fructans left behind undigested. Now let us learn about lactose related oligosaccharides. They include galacto-oligosaccharides. One of the earliest source of galacto-oligosaccharides was human milk, which contains approximately 7% of carbohydrate, 90% of which is lactose, and variety of oligosaccharides based on the lactose. Galacto-oligosaccharides comprise 1/3 largest component of breast milk and after lactose and lipids. Galacto-oligosaccharides are unique in that they contribute greatly to the protective microbiome that persists in the intestine of breastfeed infants. High levels of galacto-oligosaccharides are found in colostrum, where this substance constitutes to 24% of total colostrum carbohydrate. They are commercially produced enzymatically by trans-galactosylation of milk sugar, lactose as a substrate, using microbial enzyme beta-galactosidase, which is derived from mold Aspergillus. The chemical structure of galacto-oligosaccharide chain varies in galactose unit length with the terminal glucose unit. The degree of galactose polymerization is in the range of 2 to 8 galactose units, depend on different factors. These factors, the enzyme property, activity, lactose concentration as a substrate, enzymatic reaction, time, optimum condition, enzymatic process methods are important. The enzymatic reaction end products are galacto-oligosaccharides, free galactose and free glucose. Galacto-oligosaccharides are commercially available as a polymer of galactose in different degree of polymerization. Let us now understand the health benefits of galacto-oligosaccharides. The health benefit of galacto-oligosaccharides as a prebiotic stimulate the growth of beneficial bacteria such as Bifidobacterium species and Lactobacillus species that inhibit a growth of pathogenic bacteria such as E. coli, Salmonella, Typhi and Clostridium species via competitive excision plus enhance immune response, improve stool frequency and relieve the symptoms of constipation. They are generally considered safe by FDA of United States and of course by worldwide regulatory agencies. They are naturally present in human milk, yogurt, both human and animal milk and intestinal tracts from the milk lactose, fermentation by resident intestinal microflora. The recommended intake is approximately 0.3 to 0.4 grams per kg body weight. The only known side effect of galacto-oligosaccharide intake is transient osmotic diarrhea that occurred when digestive enzymes in the digestive system having a prebiotic properties. Now we will be learning about lactosucrose is a trisaccharide oligosaccharide composed of galactose, glucose, fructose that occurred naturally at low concentration in yogurt. When both sucrose and lactose sugars are present together in the milk and commercially produced enzymatically using both sucrose and lactose as a sugar substrate. Microbial enzymes used for this enzymatic process are levanssucrase or fructofurantosidase. Both enzymes have fructosylation activities that transfers fructose unit from sucrose to lactose. The major production method of lactose sucrose is by enzyme immobilization technology in continuous process using both sucrose and lactose sugars as a lactose sugar substrate. Let's find out its uses. This is a rare oligosaccharide of lactose sucrose, is non-digestible, non-carcinogenic, promotes intestinal mineral absorption and is suitable for low-caloric food products with multiple application as a food additive in both food and beverages such as baked goods, ice cream, candies, infant formula, juices and mineral water. The degree of lactosucrose sweetness is similar to sucrose and its functional properties are similar to other functional oligosaccharides. Now let us understand its health benefits. Lactosucrose is generally considered safe by FDA of United States and other worldwide regulatory agencies for the formulation of food and functional products. Plus, it is marketed as prebiotic to regulate intestinal microflora for selectively increase beneficial bacteria of Bifidobacterium species and inhibit enteric pathogenic bacteria including Enterobacteria family and Clostridium perfringens in the colon. The recommended intake, the suggested daily intake of lactosucrose for the adults range from 3 grams per day. In addition, lactosucrose has potential application as an excipient for pharmaceuticals and cosmetic formulation. Some research publication demonstrate that the consumption of lactosucrose as a prebiotic benefit the patient in inflammatory bowel disease. Plus, there are several patents highlighted the application of lactosucrose as an active ingredient in the drug for the prevention of some skin diseases. let us conclude, learners. We have learned that the low concentration of these functional oligosaccharides in natural resources makes the extraction process of the sources very costly. Currently, commercial production of these functional oligosaccharides are by enzymatic process using carbohydrate as a substrate for specific microbial enzyme. Carbohydrate used as a substrate for this enzymatic process are sucrose from sugar.